Okay, welcome to the third part of the lecture. Now, in this lecture, we'll try to solve some examples, and hopefully these examples will help you to understand the techniques that we follow in order to solve the electrostatic force problems. Now, let's see here, this question here. We have 2-point charges, and Q1 and Q2. As this is Q1 and this is Q2. The location of Q1 is at the origin, as you can see here, at x equal 0, means like at the x-axis in the origin. And Q2, it's only also in the x-axis at a distance equal 0.4 away from the first charge. Now, Q1 is given as positive charge, 0.15 microcoulomb, and Q2 is also a positive charge with a magnitude equal 0.35 microcoulomb. Now these are the 2-point charges. Now what's the question? The question here, where do we need to put a third charge? So now we have Q3. And for that charge to be at equilibrium point. Now this is, we don't, in this question, at this point here, we are not asked about the exact location. We just need to find the region. Now what do you mean by the region here? If you look at the figure here, you will see that we have 3 regions described, A, P, and C. Now what's A and what's B, what's C? P is the region between the 2 charges. So I can describe B as this part. This is like B. What about C? C will be this side, which is beyond Q2. What about A? A actually will be what? The region behind Q1. So we have 3 regions. Now the question here, in which region I can or I should place Q3 in such a way that this Q3 will be what? In equilibrium point. Now the question is, what's the meaning of equilibrium point? Equilibrium point means like the object in static equilibrium. Means like F3 net equal 0. At what point, actually not exactly, at what region here, well, the net force on the third charge will be 0. Now, how can we solve this question here? It's very simple if we really understand the concept of the Newton's law, the equilibrium condition, and also could apply the electrostatic force. Now, here is the thing. I have 3 regions, and all what I need to do here, I need to test each region separately. Now, in order to have F net 3 equals 0, now any point, by the way, in the space, any point in the space, if I place Q3 here, or here, or here, this Q3 here will interact with the Q1 and the Q2. So I will try to test these 3 different regions and see which one will give me the possibility to have a 0 net force. And we know, like in general, F3 net will equal what? F3 1 plus F3 2. Agree about this? Now we know, like in order to, in general, by the way, if we place it anywhere in the space, we know like the net force acting on the third charge will equal the interaction of the third charge with the first charge first and with the second charge. As we did here, by the way, if you remember, like we did here in this question, this one here, we will do almost the same thing, but instead of choosing Q1 here, we are choosing what? Q3. Now all what I have to do here, just try to apply this superposition principle. Now the superposition principle means I need to look at the interaction of the third charge with the first one and the third charge with the second one. Now, if I say like F3 net should be 0. Why is that? Because we are looking for what? The equilibrium point. What's the equilibrium points means? Equilibrium points means like the net force. The net force on the third charge should be what? Should be 0. So if that's the case here, it means F31 plus F32 should sum to 0. And if that's the case, then we can say that F31 should equal minus F32. What's the meaning of that? It means the force that Q1 will exert on Q3 should cancel the force that Q2 exerts on Q3. So I will look for the region that will satisfy this condition, that these two forces should be what? Opposite to each other. So look at this one here. Minus, if they are going to cancel each other, it means like these two forces should what? Should be opposite to each other. Otherwise, they will not be able to cancel each other. Now, that's the type of testing I'll try to apply. So let's try to do it here. Now, in order to do this, I'll try to go to the figure here and try to place Q3. First of all, I'll place it here, Q3, and we'll see what kind of interaction between Q1 and Q3. We know that Q1 is what? Is positive, and Q2 is positive. Now the question is, how can I find the interaction between Q1 and Q3, and I have no idea about what is the charge Q3 and what's the sign of that? Since it's not given, let's make a guess. Let's assume that Q3 will be what? Positive. Can I do this one? Yes, I can. There is no problem with this. So let's assume that I place the Q3 here in the region C, and this is Q3. And now I'm trying to test what is the force that Q3 will feel because of Q1. Now how do we do this one? As we said, you draw a line between Q3 and Q1, and so the force will be parallel to that line. Now, what is the type of interaction we have? The type of interaction will be what? Repulsive force. Because if I know that Q1 is positive, and I assume that Q3 is positive, so the force will be what? In this direction. So in this case, F1, 3 will be in which direction? It will be to the right. Agree about this? So far so good. Now we will do the same thing now with the Q2. What kind of interaction between Q3 and Q2? We will see that again, that the interaction can be identified by first draw the line between Q3 and Q2, and I know like the force will be parallel to that line. Now what kind of interaction? Since this one is positive, again this one is positive, what kind of force we have here? It's a repulsive force. In which direction this force will be? Again, it will be in which direction? It will be going actually, if you think about it here, actually it will be again a repulsive force, and that will give me here what? F23. And look at this one, F23 and F13, as you can see here, they are in the same direction. If they are in the same direction, it means they can't cancel each other. And it means like there is no way that we can have a net force equals 0 in this region. Why is that? Because at any point in that region here, the two forces, F13 and F23, they will be always in the same direction. And that will not, or this condition will not be satisfied. Why is that? Because they are in the same direction, so they are not opposite each other. Now, if I want to do the same thing in this side, which is like part A, as you can see here, how can we do this one? We'll do the same thing. If I place Q3 at this location, and I want to see like how is the interaction of Q3 with Q1, we will see again that this will be what? A repulsive force. And also, what's the force between Q2 and Q3 at this location, also to be what? A repulsive force, which means like these two forces in the region A, they will be in the same direction. Okay, so what's the point here? It means like they can't cancel each other. And if they can't cancel each other, it means like there is no way that we can have an equilibrium position at that region. So since C and A have this equal direction or the same direction, then we will not have equilibrium position. So the only place that left is B. Now let's see here. What about like if I make this test again somewhere in between? So let's assume that I place Q3 somewhere here. And again, assume that Q3 is what? Is positive. So let's do this one here. Let's assume that I place Q3 in the region between. This is Q3. And now let's delete everything here. You know what? Let's delete everything so you don't get confused with the previous steps. So now let's assume that I place this Q3 somewhere here. And this is Q3. Now, let's see what kind of interaction between Q3 and Q1. As you can see here, the line connected with these two, since this is positive, this one is positive, then we expect that this F13 will be what? To the right. Now, let's do the same thing now with the Q2. Positive, positive. Now, what kind of interaction? Again, Q3 will feel like a repulsive force from Q2. And in this case, what do you expect will happen here? That the force exerted on Q3 because of Q2 will be what? Will try to push Q3 to the left. And that will give me here what? F23. Now, look at this one. Now we have something to talk about. Why is that? Because you will see like F13 and F23, they are in the opposite direction. F13 in the region B is going to the right, while F23 in the region B is going to the left, which means like F13 and F23 are opposite. And if they are opposite, now we can talk. Now we can find a point in such a way that these two forces will completely cancel each other. And if they cancel each other, it means like I reach to the equilibrium point. So in this case, what's the answer for this one? The answer will be P. Now the next question here, okay, if that's the case, after we learn about this one, find the exact position that will make the Q3 in equilibrium position. Now, since I already know that the charge, this is Q1 by the way, this is Q2, and I know like I have to place Q3 somewhere in between here in such a way that now I know the distance from here to here is given from the question as 0.4 meter. Now the question is, where should I place Q3 in such a way that F3 net will equal 0? And we know like in order to satisfy this condition, it means like F13 equal minus F23. And we already know that this should be like somewhere in between. So as a magnitude, F13 should equal what? F23 as a magnitude. So if I look at the magnitude, the minus sign will be kind of dropped. So we know like what is the force that between between Q1 and Q3, we know like according to the Coulomb's law, it's K, Q1, Q3, by the way, absolute value, divided by R13 square. Again, keep in mind that I'm looking for magnitude here. So I don't care about the sign of the charge at this moment. And the second one here will be K, Q2, Q3 divided by what? R23 square. Again, I'm looking for what? Magnitude. Now, in this case, you can see that K with K cancel out, Q3 with the Q3 cancel out, and that's amazing. That's why, you know what? We don't care about the charge Q3. It could be positive, it could be negative, and that will not change the position that will satisfy this condition. So Q3 is not a factor in this one. So no matter what's the magnitude of Q3, no matter what's the sign of that charge, the answer should be the same. The answer will be only affected by what? By Q1, Q2, and the distance between these two charges. Now here's the thing. So we end up with what? This equation, that Q1 over R13 square equal Q2 over R2 square. Now the question is, Q1 is known, Q2 is known, it's given already. And by the way, we only care about the magnitude here. We don't care about the direction, the sign. Why is that? Because we already define the direction and the region. So all what we need about here is just like the distance. At what distance away from the origin? Because we already defined the direction of that, or the region of that position. Now, how can you find R13 and R23? By the way, R13, by the way, it's this one. This will be what? R13. And what R23? R23 actually will be what? This distance. R23. So this is R23, this is R13. And keep in mind that R13 plus R23, that's equal what? 0.4. How do we know this one? From the question. Because the distance between Q1 and Q2, according to this question here, if you look at it, it's 0.4. Because this one is located at origin, and this one is located as 0.4. And that's a good thing to know. Now, okay, what's the importance of this one? Now it means like I can describe R23 in terms of what? R13. So it will be this one, 1.4 minus R13. And by the way, you know what? Since we are dealing with the x-axis, I will use x as a way to define the R13. Because look at this one. Since the initial or the first charge is located at the origin, then I can call this one x. So in this case, I will be able to solve Q1 over x square equal Q2 as a magnitude, again divide by what? 0.4 minus x all square. Now here is the thing. Q1 is known, Q2 is known, the only missing will be what? X. Now I do the cross product thing, which is 0.4 minus x all square times Q1, again equal what? Q2, again as an absolute value, times x squared. This is a quadratic equation. Whatever it is, we will be able to find the answer. Now, how many solutions we expect to have? We will have two solutions. One will be positive, and the other one will be what? Negative. Which one we take? We take what? The positive. Why we take the positive? Because this is a distance. So the answer is a distance. And if it's distance, means like it should be what? Should be positive. And this is a very, very important, since we are dealing with distance, because we already find the direction. The direction or the region, we already identified that from the vector analysis. The forces cancelling each other, opposite each other, we are done with the direction. So this, in this case, we will be able to find the magnitude, and that's how we do it. Now, I think you can take it from here. Just substitute Q1 and substitute Q2 and find this quadratic equation. You will have like two solutions, positive and negative. You take the positive side. Thank you for listening.